This is an DSE question on transformation. A part is a simple algebra on the completing square. Alright. So at the beginning we have gx is x squared minus 2kx. Alright, and then we have 2k squared and 4. Alright. In order to make complete square, we need the minus 2k divided by 2 is minus k. Take the square is k squared. Alright. So we need to create a plus minus k squared out of nothing. But then the previous terms, this goes to the complete square. So that is x minus k complete square. Alright. And the residue, we collect this into the constant, that is k squared plus 4. K squared plus 4. Alright. So this is the result of completing square. Right. There is only one x now. There used to be two x's, but now there is only one x, so that is complete square. Now this has the vertex at k and k squared minus 4. The vertex will be at k and k squared plus 4. Alright. The minimum value occurs when x equals to k, so this term is 0. That is the smallest you can get. And the corresponding value of y will be k squared plus 4. Alright, so that is the position of the vertex. So there goes part A. Alright, 2 marks for part A. Now the 4 marks will be a challenge on your understanding of the transformation and also on the idea of circumcenter. Alright, we'll talk about that later on. Now first, let's look at the transformation. We have point D, alright, going to is the vertex of this graph. And then we have point E is the vertex of this graph, right? So we think about when you go from gx, right, the vertex is at k and k squared plus 4. Now it goes to g of x plus 2, alright? So where does the vertex go? Where does the vertex go, alright? We know that the movement from gx to gx plus 2 is moved to the left hand side by 2 units. Alright, this is the transformation. When you go from g to g of x plus 2, it's moving to the left hand side by 2 units. So the vertex, the point D, is also obtained from move to the left hand side by 2 units. What used to be k and k squared plus 4 is now it becomes k minus 2, k squared plus 4, right? This is the position of point D. The vertex used to be k and k squared plus 4. Now it's moved to the left hand side by 2 units. So the point D, the new vertex, becomes k minus 2 and k squared plus 4. Alright? Plus 4, right? So likewise, if you go from gx to negative of gx minus 2, right? So what was the transformation involved? So what used to be k and k squared plus 4, where does it end up? Alright, so what is the corresponding point E? Alright, what is the corresponding point E? Alright. So we know when you go from gx to g of x minus 2, there is a minus 2 here. The minus 2 corresponds to moving to the right hand side by 2 units. Alright. But there is also a negative sign here. There is a minus here. This negative means an up-down flip. In an up-down flip. Alright. So the vertex will go to the right hand side by 2 units. And then there is an up-down flip. So to the right hand side by 2 units, that would be k plus 2. Alright. An up-down flip means it is the negative of k squared plus 4. So this is point E. Alright, we have k plus 2 is moving to the right hand side by 2 units. And then we have the negative of k squared and 4. This is an up-down flip. Alright, so this is point E. This is your new point. Alright, point E is something like this. Alright, so point D will be k minus 2, k squared plus 4. Point E will be k plus 2, negative of k squared plus 4. Alright, these are point D and point E. So this is the first challenge, how to overcome the transformation. Alright, where is the position of point D and point E? Point D will be g of x plus 2. To obtain point D, we move everything to the left-hand side by 2 units. Point E is minus g of x minus 2. That is moving to the right-hand side by 2 units, and then we do an up-down flip. Alright, so that is the first challenge on the transformation. The second challenge is on the idea of the circumcenter. Alright, now the circumcenter, we know in any triangle, we can obtain the circumcenter by looking at the perpendicular bisectors. Alright, you look at the triangle, and then for each of the lines, you can find the perpendicular bisector. Alright, this red line is perpendicular to the triangle, and it is the midpoint of the line. Alright, so are the other red lines. Alright, these red lines, they are all perpendicular to the triangle, and then it is at the midpoint. Now the three perpendicular bisectors meet at the circumcenter. Right, the circumcenter. Plus, we can obtain a circumcircle. Using this point as the center, we can draw a circle, right, passing through the 3 points. So that's what we call circumcenter. Alright, in other words, for the point 0 and 3, let's say 0.3, let's call it A. Alright. So in order to be the circumcenter, we should have the distance between DA and the distance between DE to be the same. Alright, let A be 0 and 3 to lie on the perpendicular bisector of DE. That means we have the distance of DA must be the same as the distance of DE. Alright, if the point A is lying on the perpendicular bisector, then the distance of DA must be the same as the distance of EA. Alright, so we can go find the distance or the square of distance between them. So 0 and 3, so that is k minus 2 square, and k square plus 1 all square. That is the distance DA. Alright, at the same time, we have the distance of EA, that is k plus 2 square, plus minus k square minus 7, take the square. That is the distance of EA square. Alright. So you can expand those brackets. There will be a k to the 4th power here, k square taking the square. But fortunately, it will be cancelled. So at the end, I leave the algebra to you. It ends up 12k square and 8k and 48 equal to 0. Alright. In order to have the point 0 and 3 lying on the perpendicular bisector of DE, we have to have 12k square plus 8k plus 48. But if you look carefully into this one, you'll discover that the discriminant is too small. It's b squared minus 4ac, alright, is less than 0. Alright, so therefore there is no solution. No solution for k. Alright, there is no solution for k. In other words, you will never find a k so that the point 0 and 3 lies on the perpendicular bisector of DE. Alright, you will never find you will never find a k so that the perpendicular bisector of DE lies on A. In other words, you will never have point A as the circumcenter, regardless of F. The point F does not matter. Alright, because it will not satisfy DE anyways. So the claim is wrong. Alright, the claim is wrong. So this is about the transformation question, right? It involves a lot of knowledge, and it is one of the most difficult most challenging transformation question in the DSE paper so far.